is on overhead. We're looking at overhead costing, how to account for them as well, and this is what this video is going to focus on. Well, so this question there is talking about this company limited has two production departments, A and B, and two service departments, X and Y. The company has budgeted the following costs for the forthcoming period. So you have these overhead costs, by the way. These are overhead costs, by the way. Yeah, how you can tell is overhead costs are these things like rent, costs that you cannot directly trace. Those are the overheads. You cannot really directly trace them at, okay, this is coming from this, e.g. rent. It's hard to trace that, okay, rent, could it be coming from that? These costs are, they're not really, should I say, directly traced with the manufacturing process. Those are the ones they would call overheads or indirect costs. So all these they have listed for you. Now they want you to what? To apportion them. That's the whole point of doing this this process of overhead costing. So you have the overheads listed up to supervision. Then you have the following bases. What you are seeing below now are the bases of apportionment, e.g. floor area, number of employees, plant book value, machine hours. So all these are just bases. Like this is where you'll be categorizing those overheads. Like, okay, where would we take, let's say, supervision, such kind of things. Okay, we'll explain. Then we have the following costs. The cost of service departments X and Y allocated to the other departments on a percentage basis. So now after you have managed to apportion, there will be this process that we call reapportioning now, and we'll be explaining as we move using these ratios below the 55, 35, the all percentages. So overheads are absorbed in both production departments on machine hour basis. Required: prepare an overhead analysis sheet for the period using suitable bases of apportionment. Using suitable bases of apportionment. So let's answer that. So when you look at bases of apportionment, these are things like what? Okay, before we get to that, what is an overhead analysis sheet? This one is not so difficult. You just have a column where you have overhead. I've just abbreviated to manage my space here. Overhead, you have a column for overhead. You should also have a column for the basis. After a column for the basis, put in the first department. You have department A, you have department B, you have department, is it what? So you have A, B, the two production, ones are calling the production departments. Then you also have X and Y. The other, these are the ones that are calling the service. By the way, these are the other ones which normally are called the service centers. So A and B, they were stated already. These are the production departments. You just list them like that. Then you follow them with the service, and you're done. This is the format for an overhead analysis sheet. You put the total this side at the end. So let's begin. You can pick any overhead in the question. Like if you want, you can start from the first overhead given, which was rent, going down to supervision. We'll pick rent and rates. We'll start with that one, just the space, but I've just put rent. What basis can you take rent to? Let's get back to the question. So first thing you take note, okay, rent, how much is rent? Rent is at 100 there. Of course, they've debased the last three zeros, and let's just follow like that. They've removed the last three zeros. Venus will go like that. Rent and rate is at 100. Now they want to put it in a right basis. Which basis is here? Which would categorize rent? Could it be floor area, number of employees, plant book value, or machine? Where would you take rent? Rent, the best place or a basis you would categorize it in is floor area. So a basis is just a fair place you can put in a cost. Like, does it make sense for rent to go with floor area? You know, these are the questions you should ask yourself. There is no hard and fast rule now. This should always go here. There are some things which are direct, yes, but we use a fair basis. It should make sense, in short. Yeah, so basically that's what we're doing now. And then we'll take it to floor area. We've established one common ground. Now, how do you put it in floor area is the next question. Take note that floor area has got some figures already. There's a 100, there's a 10,000, another 10,000, there's a 25, there's another 25, right? In the line for floor area. Those figures will make some sort of ratio. That ratio we're going to make will be how best we'll equally distribute this 100 coming from rent, how we'll fairly distribute it in the various departments using the figures. We'll make a ratio out of them from floor area. And let me explain what I mean now. So remember, initially from the floor area, right, you can even put the basis in advance that you're taking into floor area. But take note that there was a 10, there was another 10, then there was a 2.5, there was another 2.5, right? Yeah. So you make a ratio. First of all, how do you make a ratio? You sum everything up first. Sum everything up in that basis you've chosen, floor area. You find that this is going to give you 25. What next? How do you make a ratio? It's very simple. You start. This is the first digit, 10. 10 over the total of everything will make the first ratio for the department where 10 was sitting in. And this first 10 was seated in A, and therefore the first ratio will be 10 over 25 times whatever cost you're apportioning. That's how you'll be doing it. So the ratios just make it to fairly distribute according to the figures allocated in those departments. So 10 over 25 times the 100 cost. So all of them will be multiplied by the 100 cost, because you're multiplying this 100 cost but based on what? A ratio in that department. So B has the same ratio, 10 over 25, while X will have 2.5 or 2500. I've just reduced it further, over 25. So all of them are over the total, then multiplied by the amount of this cost you're trying to apportion, which is rent. So all of them, that's what we'll do. So basically that's what you'll be seeing. So let's just demonstrate with this one, then even the next ones I'll just come and now show you a solution now after you understand this part first. So let's calculate 10 divided by what? 25. You've seen that, multiplied by the 100,000 which was there on rent. What are you getting? 40, meaning 40 quarter of that cost has to be taken to A, because that there was a ratio 10. Even B has also got 10. You also find that in B we're also putting 40. But in in X and Y, we have now 25, 25, right? So it's now going to be like 2. I've just said I've reduced it. 25. Okay, it was 25. Let's just go with it. 25 over this. That should be now 25,000 since we've taken back the zeros. Yeah. The ratio is 1.1. Then you multiply by the 100. All of them are multiplied by the cost you're trying to apportion. 10. So department X will have what? 10 quarter of that cost. And even Y, since it also had the same ratio. So I hope you've understood this, and this is how we're going to put it on the next screen. Well, so you would apportion. So this one had 40 when we said 10 over 25, that ratio. Okay, this one also has 10, so 40 is the cost. Then these had what? They had just 2.5s and they had 10, 10. So what you do at the end of the day is prove that you have really distributed the 100 kwacha. Just add everything here. 40 plus 40 plus 10 plus 10, 100. You've proved. That's how you prove. That's what goes in the total column at the end. This is how an overhead analysis sheet looks like. It's very simple. It's not complicated, just like this. Even the other costs, you just be asking yourself, okay, this other cost, maybe light and heating, where can it go? Once you know the basis, you even record, okay, light and heating, maybe you take to this place. Once you know that, now look at what are the ratios in that basis, just like we've done. You make ratios. How do you make a ratio? Just sum up first all the total figures in that basis, sum them up, then start saying, okay, in this department there was a 10 over the total of that summation. That's important. That's how you do the ratios. And that's the next thing I'm going to see on the next screen. So well, you can now have a look at what's on the screen. This is what we were calling an overhead analysis sheet. Look at how it is. The same format I showed you, and how we have distributed what? These costs. So the next one was what? Plant insurance. Where do you take plant insurance? The best place is that you look at what names are there. There was plant book value, and since there's that plant name there, it was the best basis actually. Okay, then heat and lights, it's flow area. That's the best one, because you look at heat and light, where would you best attribute such a cost? It's flow area. Flow area will take most of these things, heat and light, rents, which other things, but mainly these ones. Yeah. And then canteen costs, it's about employees. Yeah, that makes more sense, because who goes to the canteen? This would make more sense. It's a number, it's the employees. Yeah. Then you look at what? Light and heating, same story, similar with the same heat and light. They're all going to flow area. Then supervision also makes sense to take it to number of employees. So these things, as I said, it should be a fair basis, should make sense in short, and that's how you categorize them. Then, as I said, how we're making ratios, we just sum up that entire basis. So let's say you go to number of employees as the basis you've chosen, you sum up whatever figures they've put in the number of employees row, then you start making ratios as we're doing. Yeah, and that's the overhead analysis sheet you come up with. So the first one was just a demonstration so that you can see the entire process for the rest and understanding how we've categorized the other ones. This is the first step, the apportionment, which is done in the overhead analysis sheet. The next question is reapportion service cost centers to production cost centers using algebraic method. What is that? Algebraic method. Okay, this method, also known as simultaneous method, using simultaneous equations to apportion. to reapportion, these are actually reapportioning methods. I'll demonstrate. It's like a mathematical way of trying to reapportion these service centers. And which ones are the service centers? As I said, it's X and Y. Okay, they even mentioned there, read the cost of service departments X and Y. That's how you know they're the ones. Yeah, so hence that's the one we're looking at. So we're going to use these same figures you're seeing there. They said that they will are allocated to the other departments being A and B as the following percentages below. So there's 55%, what, and so these are the ones we're going to use to make equations. So let's do this. Since it's X and Y we're trying to reapportion, we need to make equations for X and Y. That's how it goes. So make an equation for X, make an equation for Y. Take note of the total here for X, 48.5. I'm sure we're together there. Total for Y, 50.5. So far we know that X, this line for X is equal to what? 48.5. While for Y, what is it equal to currently? 50.5. Now let's make an equation. Having known that, okay, so far X is equal to 48.5. What else do we need to add on to that? Well, you're trying to make the equation for X and Y, as I was just mentioning. So let's start with X. So far we know that X is equal to 48.5. But these ratios you're seeing here, these are percentages, by the way. They are the ones that are going to also help in the reapportioning process. So we also consider them as we are reapportioning, and I'll be explaining. So you're just trying to make an equation. X is equal to 48.5 according to the total that you just found from the previous overhead analysis sheet. But plus what? There's still some cost that is sitting in X that you cannot also ignore. According to these ratios or percentages given, notice that X also has a 15 seated in its line. Have you noticed this 15? As I was saying, these are percentages. There's a 15% sitting in there. But in relation to which one? So this 15, you will see it's corresponding with Y this side. It's in the line for Y if you want, the row for Y. Therefore, it's showing you that 15% of Y is part of X. And you have to add it here in this equation. So I'm saying you just want to make what is X equal to entirely. So it's also equal to 15% of Y. Why aren't we putting anything for Y? Because these are equations. We're coming to solve for X and Y. That's why we're leaving the X blank and the Y blank. But we just have to make an equation. That's how the algebraic works. Go to the next one. Y. We're now for Y. Because we're just reapportioning the service departments and there are only two. So go to Y now. So for Y, take note that it's here. It's in the line. Okay, Y so far face is equal to 50.5 plus what? Take note that you come this side, sorry. In fact, it's in the line for X. If you look at it, Y, this 10%, the 10% that is seated in the Y column, this Y column, there's a 10 seated there. That one is coming from where? It's coming from X, showing you that 10% of X is part of Y. Hence, you also say 0.1 X. That's the equation. So you just make an equation based on what are these two equal to, these service departments, and whatever they are showing based on also the ratios. Apart from their first acknowledge the total first from the overhead analysis sheet, then add on whatever the ratios so showing, then you're done. Then now let's do the process. So at this point, you're just going to solve for X and Y given these two equations. That's all. Meaning, what can you use? You can apply simultaneous equations, those rules. So here we can apply that rule, not elimination method, but we can try substitution method. Yeah, I'll be explaining as we move, but we'll try substitution method to solve for X and Y. It's just another method in the simultaneous equations. Yeah, so we start. So remember there is a 48.5 plus 0.15 Y. So what you can do is that you have the X is equal to this. Y was also equal to something. The substitution method works like this. Since there's a Y here in this equation, you just take whatever this Y equation that you had made, the 50.5 plus 0.1 X, put it in here. Put it on where there is Y. Just substitute. That's how substitution works. Just substitute this part where there is Y. So it will be like 48.5 plus 0.15 open brackets, because it was supposed to be Y, but we're now substituting the Y. What is Y equal to? 50.5 plus 0.1 X. Then you just solve where X, of course, X is equal to this entire equation here. Then you just solve for x, and for sure you get your answer. You're just solving for x. Simple math. You know, there are brackets here, right? There's this figure outside the brackets, but it's supposed to multiply everything in here. The normal laws of math, huh? The figure that is just right outside the brackets is signifying the multiplication of whatever is inside. So you're going to multiply 0.5 times this, 0.5 times that. Those are the simple rules from math. Huh? You expand the brackets and you even add it this side. There is x at some point. You have to come and marry the two. So let me show you the calculations that have been done now. So have a look at my solution there. The same equations I earlier stated, the x and y equations. Huh? Then we are just, like I said, okay, let's substitute y. We put in y, and you can see the breakdown of the calculations. I think this is now clear. Let me just zoom in. You can now see the breakdown of my calculations, and we therefore found that x is equal to 56.93. What about y? What was the value for y? Having known x, you just pick the other equation for y now. Okay, you're now solving for what? For y. Therefore, you just substitute in the y equation, which was 50.5 plus 0.1 x. But now you know x, you put in the value for x, and you get y. It's that simple. So the first step is one just looks a bit challenging for solving for the first variable. Once you get the first variable, it's very easy. Just use one of the equations and so forth for the other one. And that's the y. What next after this? You're not done, by the way. You've just found the value of x and y. It's not the end of the process. Huh? What you're now supposed to do is now take it to the same table and finalize the reapportionment. So the first step is, as after you find the values, go back to a table like this. This is the table that we use for the reapportionment process. So you have found the value of x and y. Those are the same ones that are going to be used to eliminate x and y. Because the whole point of reapportionment is to get rid of the service centers. So let's start with okay, let's put in first all the values. X was equal to what according to our answer that we found? 56.93. You put it in brackets because we're trying to eliminate. It can be a positive figure. And then this other side, we found 56.19. You put in, initially you put in everything. Then remember, there were ratios, okay? Just before we put in 56.19, first of all, let's start with x. In fact, it's one at a time. Yeah, so remember there were ratios. Like x had some ratios like this. Is it 55, 35, and 15? Sorry for that. It's 10 there. Those are the ratios that were given initially. These are basically how we are going to reapportion x based on those ratios. They always give these ones at least, or they'll give other further instruction. Yeah, so you are going to use the same percentages to reapportion what's this? X. So let's start. As I said, always when you're making ratios, first you sum everything up and then you can start making this over that. So since we know 55 plus 35 plus 10 is 100, so anything over 100 is also as good as saying, you can just even make a percentage, because like out of 100, you can just say 55 out of 55 divided by 100 is just like 55%. Okay, so that even makes sense. So you can just say 55% of x. Okay, because this is how we are going to apportion x. 55% of x should be taken to a. Why? Because this figure 55 is seated in the line for a, meaning whatever percentage you charge from the x value should be taken to department A. That's how you understand this. So these are the ratios. Understand the ratios there. 1, 2, 3. These are how you are going to distribute the cost for x. So where is the ratio seated? That's the department you take. Simple as that. Then we start. Okay, the cost is 50. We have the cost of 56, I believe. That's 56.93. Let's reapportion that one. This one is supposed to reapportion. So you start. What is 55% of that? We put in. This one I found 31.31. That's the 55% of 56.93. The other one, 19.925. The next one, 10% of this, 5.69. Okay, that's basically how you handle this. You can even put the 3 if you wanted here, but yeah, that's basically 10% of that amount. Then you've finished. You've distributed this cost according to the ratios. At some point, it will give you 0 because that's the end game of reapportionment. The service center should give you 0. But first, do for X and do for Y. Don't just say, oh, I've done for X, but I'm not seeing any 0.8 in X and Y. Just wait. It will review itself. Huh? That's the thing with the algebraic method. Automatically, it will cancel. That's why the process is find the values first for X and Y, because those are the figures that will eliminate. So let's go. What was the value for Y? Because we also have to try and get rid of this department using the value. So always when you're getting rid of a department, start by getting the value that you had initially calculated. So this one we calculated 56.19 as well in brackets because we're trying to eliminate. Then what were the ratios for Y? They gave us 50, 35, and 15. These were the ones that were given. So 50 was in relation to A, 35 was in relation to B, 15 was in relation to X. Then just distribute this cost 56.19 fairly according to those percentages. So what is 50% of 56? We put as well. Well, let us now so I've basically done the distribution. So 50% of the 56.19 was this one, the 19.67. Then the 35% of the 56.19 was 28.095. Then this was 15 in X. 15% of 56.19 is 8.43. So at this point, you have the values for Y. Let me just eliminate them. Let's just keep this side to 2 or so decimals. That's 5.69 there. I was just cancelling off the 3. So let's add this total here and add this total in here in X and in Y. You should get 0. Like, try it. You'll get 0. So my summation has shown me that it's actually 0 that we're getting. Huh? We're getting 0 in these two departments. You have achieved the zeros just by those two figures that were found using the algebraic or simultaneous equations. So this is how this method works basically. So you find the values, then you come to this table. As how do you open up this table? This table starts with first the original values as of the overhead analysis sheet. Always remember, when we are beginning any reapportionment process, using any other method of reapportionment, start with first the values coming from the overhead analysis sheet. Or they will tell you something that, okay, these departments have so far these values, but they want now to reapportion. Maybe then they've already passed their overhead and they've just given you the overall totals. But always when you have an overhead analysis sheet, pick those final totals and open up this table first, then begin the process of reapportioning depending on the method. But here in this video, we have used algebraic or simultaneous method. So you get your zeros. Even here you can sum up, and let me show you the solution of how this came out. So basically what has been said is what you're seeing on the screen. That's the final outcome of the reapportionment. You get your zeros in those two departments, and that's the end game. The service centers have to be zeros because you're reapportioning them to what? To the other, that's what they said, the other departments, which is A and B. Yeah, so they are getting rid of them. And you even find the totals in A and B, the new totals, because you've now put in some extra costs you get, they cannot stay the same. So that's why the A has become 232.98, the other one has become 194.02. So what you can do with these two totals, you can also prove that you've done the right thing. Sum up the two totals of A and B and see if they will add up to the overall summation that you got when you sum up all the totals in the overhead analysis sheet. There are those totals which come up at the end when you're done with the overhead analysis sheet. Sum those totals and sum these two to prove that you've done the process correct. They should be equal. And basically that's it.